Okay, this is a little mini lesson, from Mr. Dahlstrom's pre-AP physics class. This is over a problem that is on the back of our linear motion problem review. This is something we went over in class. I also drew a diagram for my students on the board that was much easier to understand than what's going on here. I'll read this through here and then I'll talk you through this whole diagram. Looks super complicated. Really, it's not, especially if you think about it in terms of the red, green, and blue section. So let's first read the problem and I'll talk about why it's better to not answer it as an A, B, and C. So it says, actually I'll have a picture here to explain here. So this is my rocket, okay? So it says, a catapult launches a test rocket vertically upward from a well, giving the rocket an initial speed of 80 meters per second. Basically, this is a justification is why is this rocket already moving at 80 meters per second when it's at ground level? Don't worry about that part. Just understand that the initial velocity for this red part, as we see the red part is red, part 2 is green, part 3 is blue, is 80 meters per second. It says, the engines then fire and the rocket accelerates upward at positive 4 meters per second squared. So instead of using g here, we'll substitute g for positive 4 until it reaches an altitude of 1,000 meters. At this point, its engines fail, or they cut off, and the rocket goes into free fall. So basically, the first part of the problem is red. It goes into free fall, so it goes up to its max height and then down. Now, I want to be clear, how you're going to solve this problem is not how you're going to solve it in class. We're only choosing to split it up in these 3 different parts because we're not having to know all these different little things rather than just what's the final velocity or what's the time. So don't solve this, or sorry, don't solve the ones we've been working on for 2 weeks like how we're splitting this problem up here. So this is very specific here. So if you look at what you're having to solve for, you're having to solve for what the time interval is in the rocket and motion above the ground. That's pretty. You can't just solve for that all in one equation. That's why we need to split it up. Also, what is a maximum altitude? That's also a 2-part problem. And then what is velocity just before it hits the ground? So how fast is it going when it hits there? So I've basically created this diagram to make it a little bit more clear, and I'll zoom in here now that we have what the problem is. Okay, let me check something. Okay, and so let me go ahead and refocus my camera. So once again, we're going to want to look at the red part. That's the part where it's positive acceleration, where it's going up. The green part starts right where the red part ends. So now it's in free fall, meaning that there is no other acceleration other than gravity, and then goes up to its max height. Now, to be clear, there is no real arc here. We're not doing projectile motion yet. We're not saying it's moving here. This is just easier to show rather than red, green, and blue being on top of each other. So there really would be no sideways motion here. Doesn't matter. That's just the simplification. So once again, goes up to here until the rocket cuts off. Now it's in free fall. Well, it's not falling yet, but it's the only acceleration is gravity, and so it goes up to this point. And then the last part, we're choosing to look at it like this because it's easier to break up the times. It basically, from its max height now, it's now in free fall. The velocity here is 0, and we're having to calculate not only what the time is, but the final velocity. So there's 3, basically, you want to solve the red part first. So the red part, you can pause this or play it whenever you want to again. Instead of trying to solve for the total time, maximum altitude, solve for these 6 values first. And then once you do that, you go down here and say, oh, well, the total time is just the 3 times, and the maximum altitude is just our 2 delta y's. And then you can solve for VFY3 as you always do. I do have the answers over here. Obviously, you should have some work for that, just to give you an idea of my work. My work is obviously more, I would write it a little bit better, but I have stuff all over the place. Plus, I have this picture, which you wouldn't necessarily have. So the first part you would do in part red is, you know, the initial velocity is 80. You know delta y when it gets to that point is 1,000 meters. You know the acceleration is positive 4. So instead of using negative 9.1, you use positive 4. You should be able to, this is a recognition, we don't have the final velocity, we don't have the time. That is that 4th equation, second equation strategy I've been talking about. So you can find the final velocity and the time there. This should be about 120 meters per second. Let me check. And this should be 10 seconds, just as you're going through. Okay. The next part is the green part. The green part is you're taking off right from the red part. The key part here is realizing that the initial velocity for the second part is the final velocity at the end of the red. So yes, it ended at 120 meters per second when the engine's cut off, but that's now how fast it's going while it's under free fall. Okay, you know gravity's negative 9.1. We know up to this max height because we need to try to find what's this distance here, max height. We know the final velocity should be 0, so you can use your equations to find what is delta y2, I mean it's just the delta y for the second part, and what the time up for the second part is. This delta y2 should be 733.94. What's the time? I think the time is like 12.23 seconds here. Just you can replay this here, but obviously these are the final answers that you're getting to. So the last part here, because we had to split up the other two parts and we're basically starting from the max height, that if it's not moving at the very beginning, that means that the initial velocity for the third part, the blue part, is 0. So that's very helpful. We're still under the free fall, so negative 9.81. And you need to find the time for the third part and the final velocity of the third part. Once again, this is a fourth equation, second equation strategy. The thing that you need to also know is what delta y is. So realize with delta y, it's negative the max altitude, because remember, it's not just falling 1,000 meters, it's not just falling 733, it's falling down 733.94 plus the 1,000. So that should be negative 1,733.94. When you calculate that, if you don't get that, that's obviously you need to check your calculations, but you should be able to use that information right there, fourth equation, second equation, find what the final velocity was, understand that that should be negative. It wasn't negative here. This is the one time we've ever had it not be negative, is because it was still going up. But just like we've been working on in class, because this is about to hit the ground, you have to choose the negative, because the square root is plus or minus, and that should come out to negative 184.44 meters per second. And then basically you can go and answer the A, B, and C. I recommend you do this on a separate piece of paper and just had red part, green part, blue part. That's what people are doing. Or if you're going to use this, just cross out A, B, and C and just solve for the red part, green part, and blue part. But also remember you have to solve for that, that, and that. So the total time should be T1 plus what you got for T2 plus what you got for T3, and that should come out to about 41.03 seconds. Your max altitude we just talked about is your delta y1, that's how far it went in the edge of cutoff, plus whatever your delta y2 is. Once again, that should be positive. Your max altitude, we're measuring upwards, as opposed to this one where we're measuring the displacement, is 1733.94. And as we talked about, you find the final velocity and it hits the ground there. So that should be enough of an explanation. If you need more of an explanation, you can obviously contact me, but this is Mr. Dahlstrom's explanation of that. And as I said, this is not extra credit, but is an optional assignment, meaning it just adds, it puts more points onto your grade book. And basically everybody in the class did it. The only people that didn't were people that apparently didn't want 10 points. So you can do that. I'm going to create a separate assignment on Schoology, and you can put that in there. Obviously, if I'm giving you the answers and telling you what things should be, I should expect work for each of these. That's why if you split it up into the red part, I should see the work for that and that. The green part, I should see the work for that and that. And the blue part, work for that and that. And then at the end, you show me the work for that, that, and that. So it's not so bad. I do appreciate you signing in. Hopefully it wasn't too long a video. I think we kept it at 9 minutes. We'll try. So I appreciate it. Expect, depending on how you are quarantined or how you are out, we are going to test over this. In class, we're having a test, not over this. We're having a test over the linear motion review and stuff like that on Wednesday. Today, Tuesday, I put up the Kahoot review that we're doing in class that's open for you to play. So whether you're coming back in a few days or whether we have to schedule something like taking a test at home, just make sure you're following along with that. You don't want to get too far behind. Been really proud with everybody so far, but I really recommend that you do this problem. It is part of the, once again, the linear motion problem review. It's just on the back. If you do it separately, obviously, if you're bringing it in, you give me a hard copy, but otherwise submit it as an assignment. I do appreciate it. Do subscribe. Maybe get more than 17 subscribers because I'm going to start putting more videos, smaller videos out, especially for Vector Edition, where it can get pretty long in some cases. So I appreciate it. Look out for the next video.